All right, welcome to This Explainer. Today we're looking at something that, well, at first glance might just look like a simple side dish, but let's get one thing straight. We aren't just cooking today. Based on our source material, we're actually analyzing a highly efficient delivery mechanism that requires some seriously precise thermal management. We are diving into the Avocado Pico de Gallo rice culinary protocol. To really grasp the stakes of this mission, just listen to this quote straight from the source text. Quote, attempting to fuse a hot, gelatinized carbohydrate matrix with a cold, raw, highly volatile acidic matrix, end quote. I mean, if you don't execute this correctly, you're not just making a mediocre meal. No, you are actively engineering a disastrous, oxidized gray mush. We're dealing with incredibly volatile components here, folks. Precision is literally everything.
So, here's your mission briefing for today's explainer. We are going to proceed sequentially through 5 stages. Protocol Alpha, carbohydrate gelatinization. Protocol Beta, the acidic matrix. Protocol Gamma, lipid preparation. Protocol Delta, thermodynamic fusion. And finally, the red team report covering failure states.
Let's initiate the first phase of the operation. Protocol Alpha, carbohydrate gelatinization, preparing the rice base. Okay, let's dive right into this. We start with the carbohydrate base, right? 1 cup of long-grain white rice. Think basmati or jasmine. But the absolute secret to success here lies in dealing with amylopectin dust. What is that? Well, there are these highly branched carbohydrates just clinging to the outside of raw rice grains. If you don't mechanically strip this dust away by washing the rice under cold water until it runs completely clear, your carbohydrate matrix is going to fuse into a gummy, clumping disaster. Skipping this? Guaranteed mission failure. It's an absolute requirement.
So once it's perfectly washed, we follow a very strict operational procedure. Step 1 was the wash. Step 2 is hydration and heat. Combine the rice with exactly 1.5 cups of water and a half teaspoon of kosher salt. Bring it to a rolling boil, and then, this is key, reduce the heat to the absolute minimum for a 15-minute simmer. But step 3 is where the real discipline comes in, the thermal rest. You leave it covered entirely off the heat for 10 minutes. Then, you take off the lid, fluff it with a fork, and let it sit uncovered for an additional 5 to 10 minutes. This final venting phase is critical to release all that excess steam.
And you know, that venting phase, it's all about hitting a very specific target. It comes down to this number right here, 140. The core temperature of your rice must drop below 140 degrees Fahrenheit, which is 60 degrees Celsius, before you even think about proceeding to integration. Why does this matter so much? Well, the big takeaway here is that if your rice is hotter than 140 degrees, you will literally boil the delicate raw vegetables we're about to prepare. You have got to respect the thermal differential.
So, while the rice undergoes its mandatory thermal rest, we shift our focus. Protocol Beta, the acidic matrix, constructing the flavor payload.
To build our aqueous payload, you're going to need a 1/4 cup of finely diced red onion, 1 minced jalapeno, and make sure the seeds are removed so you can actually control the capsaicin load, the juice of 1 fresh lime, a half teaspoon of kosher salt, 2 diced Roma tomatoes, and a 1/4 cup of fresh chopped cilantro. You're going to combine and macerate all of these together in a large mixing bowl.
But listen, we aren't just tossing a salad here, okay? We're actually orchestrating a chemical battle against isoalene. Isoalene consists of these harsh sulfur compounds naturally found in raw onions. It's what creates that really unpleasant chemical bite. And this perfectly illustrates why we build the matrix this exact way. The citric and ascorbic acids in the lime juice literally denature those sulfur compounds. The acid completely neutralizes the bite while perfectly preserving the onion's structural crunch. It is literally chemistry working for your palate.
Now that the acid matrix is fully active, we move to Protocol Gamma, lipid preparation, securing the avocado.
All right, for our delicate lipid payload, we need 1 large, ripe Hass avocado. You're going to slice it in half, safely remove the pit, and score the flesh into a perfectly uniform 1/2-inch grid. Once it's scored, you scoop those uniform cubes directly into the highly acidic Pico de Gallo matrix we just built.
Now, why drop the avocado directly into the acid like that? It all comes down to polyphenol oxidase. This is an enzyme inside the avocado flesh, and when it gets exposed to oxygen, it reacts to form melanin. Yep, that's that unappetizing brown pigment you've probably seen on day-old guacamole. By tossing the avocado right into the matrix, you immediately coat it in lime juice. This creates a physical ascorbic acid barrier that completely blocks the enzymatic reaction. It keeps your lipid payload a vibrant, healthy green.
Okay, all components are now prepped and stable. It's time to initiate Protocol Delta, thermodynamic fusion. integrating the matrices. This is, without a doubt, the most delicate phase of the entire operation. You take that slightly cooled, fluffed rice, remember it has to be below 140 degrees, and transfer it directly into the bowl with your avocado pico de gallo matrix. Then you execute the fold. Using a silicone spatula, you perform a gentle, bottom-up integration. I cannot stress this enough. Do not stir aggressively. If you panic and start stirring this thing like pancake batter, you will crush the delicate lipid payload into a green paste. You'll utterly destroy the intended structural contrast of the dish. So gentle, disciplined folding only. Finally, you conclude the fusion protocol with a quick calibration, taste for osmotic balance. Because you just introduced a massive carbohydrate base to the mix, there's a good chance it might mute the vibrant acidity of your matrix. If that happens, no worries, you just need to adjust. Add an extra pinch of kosher salt or a quick splash of lime juice to restore the balance. Once it's calibrated, the protocol dictates the dish must be served immediately. But what happens if you don't serve it immediately? Let's debrief with the Red Team report, failure states, counter-analysis. We really need to talk about the extreme biological limitations of this completed dish. Let's play devil's advocate for a second and look at the catastrophic batch prep failure state. If you try to meal prep this and put the fully fused dish right into the refrigerator, you trigger a nasty process called retrogradation. This is where your beautifully gelatinized, fluffy rice turns completely hard and gritty because of the cold environment, and actually it gets worse. In the fridge, those fresh tomatoes will weep their cellular water, creating a gross, soggy puddle at the bottom of your container, and eventually the avocado will overcome its acid barrier and oxidize anyway. It's a total, complete systemic breakdown.
So, storing the fused dish in the fridge? Absolute guaranteed failure state. Just do not do this. If you absolutely must meal prep this recipe, the only acceptable correction is a modular storage method. You have to store the cooked rice in one airtight container and the raw pico and avocado matrices in completely separate airtight containers. Thermodynamic fusion must only occur at the exact moment of consumption.
And that brings us to our final, highly restrictive metric, 4. That is the incredibly short biological shelf life of this recipe once it's actually combined. The fully synthesized dish must be consumed within a strict 4-hour window. After 4 hours, the textural contrasts begin to collapse, and the structural integrity of the entire dish is compromised.
So you've learned the science. You've mastered the thermodynamic fusion of the avocado matrix. But the real question is, are you disciplined enough to execute the protocol and consume it before that acid barrier fails? It's a pretty fascinating way to look at what happens in our kitchens every single day, isn't it? Not just as cooking, but as literal, applied chemistry and physics. Anyway, thank you so much for joining me for this explainer. Keep this protocol in mind for your next culinary mission, and I will see you next time.